And I'm going to share my screen. And so Leah and I are just going to do like some quick intros to ourselves. Half of you have already taken a class of those before, so this might be a little repetitive. Thank you for dealing with that. And also, I guess, oh, we also haven't even, have we done this yet, Leah? We haven't, right? Okay, cool. So just some structural things about this class is, this class is an experiment. So this is actually the first time we're teaching this particular course. Many of the other courses that we've taught multiple times, and we've kind of like gotten to a certain level with those classes. This is kind of a new one for us. So the first thing to know is like this class is really about what you want to get out of it. So if you feel like you're not getting the things out of it you thought you were, let us know, and we're happy to sort of veer into that course or whatever. Yeah, so this is a brand new class for us, so we're going to try to see how it goes. And my guess is that we've set up a schedule for the next 4 weeks, but my guess is that that will change based on feedback from people, questions we get, that sort of thing. So bear with us as we like shift things around, but also like feel free to weigh in when you have certain things that you'd like us to work on or talk about. So objectives for this class are like, if you've taken any of our classes before, like the number one thing that we want you to get out of this class is that you make stuff. You know, I personally think that like the only way to really learn how machine learning works is to just do it and like mess with it and break things and fail a lot. The point of having Leah and I around is that like we can help you with those things. So you run into issues, reach out to Leah or I. Like we're happy to help where we can. You know, the point is that in the next 4 weeks, hopefully you have like a good support system through Leah and I to like help make the things you want to make. And even if you can't make the things you want to make, like learning a little bit about why that's hard or why you can do it. This class will cover some basic concepts of machine learning. I think next week we'll actually go more into sort of like what a model looks like and what you know, what layers are and those sort of things. So we'll go through some notebooks that help us sort of understand that. Obviously the big thing here is we want everyone to learn to know how to use Colab, as well as like converting and using models you find online. So we'll be doing a session in either next week or the week after on just like, you find a GitHub repo that looks cool, how do you move that into Colab and begin to play with it? And obviously the last thing is we hope everyone can make something cool out of this class. So schedule for the next 4 weeks. Again, this is TBD, but I think this is sort of where we're going to land, or at least going to try to work with things. So today is going to be mostly intro. We're going to talk a little bit about Colab, get you set up and running with things. Next week will be a little bit about how different people write notebooks. And then we'll look at some demos that explore like actual networks. So actually when you hear deep learning, that like those are essentially layered networks. So we'll actually look at some of those layers and try to like debug what's going on in them and how to understand them a little bit better. Week 3, week 3 we'll cover converting models. We weren't going to do training in this class, but based on the last class that we taught, like everyone wants to know about training. So we're gonna touch a little bit on training in Colab. It's a little bit of a messy topic, but we'll at least cover it so that you can try your hand at it and see how it goes for you. And then we've heard from a lot of folks that people are really interested in StyleGAN. So week 4, we'll go over some notebooks. I have a ton of notebooks just all around StyleGAN. So we'll look at some StyleGAN 2 notebooks to do lots of different types of things with them. If you've taken a class of this before, you know that you can schedule one-on-one with us. So basically those will be like 20-minute periods where you can sort of talk to us about questions you're working on in your projects or something maybe you didn't want to ask in a group setting. So those will usually be scheduled around week 3. I personally will say I've been bad at them this week, so I owe some people some emails. So basically one-on-ones are meant for us to find time to work together, but also all of us have crazy schedules. So what I would recommend is schedule your one-on-one like as soon as you can. So when it's available, just schedule it. And if you need to move it, if Lee or I need to move it, it happens. But just basically, like I find that if you put it on the calendar, you'll have questions and you'll work on stuff for that session. It's a little bit better than trying to wait for the perfect moment to schedule it. I'll also say the one-on-ones like don't really expire. Like you can just schedule it whenever you want to. If you want to do it 3 months from now, that's totally fine. But I just generally find that if you do them, you know, a week or 2, like after the class is over, like you'll remember to do them and have questions and things. So we'll post links to that when it's available. Homework expectations. So I would say you should expect about 2 to 6 hours of homework every week. This can vary depending on obviously what you want to get into and also just like your own time commitments. But I think 2 to 6 hours is probably about right. If you want to do training, it will definitely take more time to get set up. And obviously making data sets is a large part of that work. Maybe you've already started one, maybe you haven't. If you are interested in training and you want to learn a little bit more about making data sets, which we won't cover in this class, Leah and I have lots of videos from previous sessions on making data sets. And we're also teaching a class next month that is all on data sets. So I think there's 1 or 2 spots still open up for that if you're interested. I always bring this up because lots of folks in here are working professionals and we're in the middle of a crisis and maybe you have kids at home and any number of things. So potential approaches for this are, follow along every week and do every homework assignment. That's what we would hope to see people do, but we recognize everyone has different time commitments and that sort of thing, especially right now. Another approach is just, follow along each week and then try to figure out one big project you want to work on and maybe get started and do a little bit every week. This isn't a class where you're graded on anything. So like if you decide not to do any homework and you decide to just hang out and listen to lessons every week, that's also totally fine. I do find that you will learn more by making stuff, but we're all adults here. I can't tell you what to do. So, obviously if you're really busy, you might just want to sort of soak this in and start thinking about it. And then when you have some free time, start working on things. All those are valid approaches. Just to put that out there, like I'm not expecting everyone to do every homework assignment. Sometimes people apologize to me that they didn't get to do the homework this week. And I'm just sort of like, you're an adult, you've got things going on. So do your thing. I don't frown upon anyone who like doesn't finish homework assignments. It's totally fine. There are many, many materials for this class, and Leah and I have tried to do our best job of like sort of consolidating them into one place. That one place will be this class site. It's just a GitHub page, and it just sort of like every week we'll list links to the videos, slides, notes, links to other things that you're going to need to do. We'll list the homework assignments there. So if you're going to look at any one page or bookmark any one page, it should probably be this class site. This class site already has, it's linked to in the Slack channel, and it already has links to the slides from today, as well as some links to things that we know we're going to talk about. And then the video, when it's finished processing, will also be uploaded and linked to from here. So in general, I would say like this is also linked to from the top of the Slack channel. But in general, I would say start here. This should be everything you need. And if it ever falls out of behind or whatever, like just like ping Leah and I, and we'll make sure that it's updated. There is a GitHub repo for this class as well. Again, I don't know how familiar people are with Git in this class, and you don't really need to be familiar with Git. But basically what's going to be linked here are some Python notebooks that we'll talk about directly in this class. So in some cases, I don't link these to like the ML Art Colabs repo. If it's just like one of these is just an intro to Colab for us, a snippets thing for this class, like that sort of thing. So this will probably be the only thing that's linked to from this GitHub repo, or just some notebooks to play with. But again, if you want to check that out, you can. Videos, so we talked a little bit about videos. We will be recording videos. They usually go up a couple hours after class is done. Slides, everyone is going to have links to slides, so you can review them at any time. There's links in there that we will also try to cover in the class site. But if you want to read through the slides, make notes, comments, whatever, you can do that as well. Notes sometimes happen. It just depends on sort of like who's teaching what and when. Leah tends to take better notes than I do. So if she does some good notes, she'll link to them. And then lastly, our Slack channel. We love when people use our Slack channel, but obviously like people have Zoom fatigue, Slack fatigue, online, everything fatigue. So there's no requirement to use our Slack channel, but just so that folks know what it is in case you're not here yet, there's a private channel called Colab class. You can just, if you're not in this class or if you're not in this already, just let me know and I can add you to it. Just make sure you're signed up for our the Artificial Images Slack. While I'm on the topic of Slack, there are many, many other channels in here. Most of them you don't have to concern yourself with unless you're really interested in it. All of these the topic should be like fairly apparent based on the channel name. The one I'll point you to, which I think is also like a good thing for you to share things in, is the Share Projects channel. So I have a bunch of former students who are sharing things, every week or so, people post a link or two. I highly recommend that you share some of your work there as well. So if you make something cool, share it, because I think people are really interested in it. People also often have questions about like, hey, how did you do this? What are you using? That sort of thing. So the Slack is it's not a super active community. I would say you see a couple of posts every week, but I hope it's like a good resource for people. Other things that might be of value for you to check out there is actually a Colab channel called servers-collab. And people will post links if they find cool notebooks there. It's mostly Leah and I, but a couple other people have posted cool things recently. Like if you're interested in pose tracking, Caitlin just added a open pose notebook for some pose tracking. So that's cool if you're interested in body movement or that sort of thing. Let's see, what else? So a note about just sort of how we teach these classes. Classes are mostly for us to do lectures and discussion. So we will sometimes do demos in class, but oftentimes what we'll do is we'll like talk through the process and then we'll link to a video on YouTube that like goes through the full demo. That's just better because then you can follow along at your own pace, right? Some of you have really good technical skills and some of you are still learning. So some of you will want to pause every second, or maybe you'll want to even ask questions of Leah and I like as you're watching it over Slack or whatever. So this sort of helps us. It also helps with like demo fails, which I am always is happening to me. So just be aware that like a lot of times there'll be extra materials outside of class that you'll want to watch in order to keep doing the homework. I'm going to try to keep those links like up to date as soon as possible on the class channel, because I know like, this is like a Sunday morning, Sunday afternoon class for a lot of folks. And maybe you want to spend the rest of your Sunday keep trying to play with stuff. So I'll try to keep the links on the class site up to date as soon as possible. Leah has also set up a poll for working sessions. So working session is essentially like a place where you can, like we'll find a time to just like we'll find an hour or two in the week and people can join ad hoc and like just share some work or ask questions of Leah and I. This is kind of a nice way. We previously tried to do like a Q&A session after every class and people then felt like class was like 2.5 hours long. So this is a way for us to sort of reduce that Q&A fatigue. Basically what we'll do is we'll post a note in the Slack channel like an hour before the working sessions happen. If you are going to show up at any time during that session, you don't have to show up immediately. Just let us know with like an emoji response. That way we know to keep an eye out for people. If no one responds, like we just basically like Lee and I will go about our day. So it's an optional time, but it's a good time for people to check in with questions or, I assume like, especially this week or next week, people will be like, is there a notebook to do this? Is there a notebook to do that? And we're happy to like help do that. If you can't attend the working session, you can also just post questions in Slack. That's totally fine. So last note on technical level for this class. So this class is meant for people without like any technical knowledge. Like the idea is that you'll learn a little bit of Python, you'll learn a little bit of Colab, but you don't have to know those things. I know based on the feedback from our poll that many of you do know Python. And my guess is that many of you are interested in sort of getting into the guts of a neural network or whatever. That's a bit of a challenge, especially in this class. And I'll talk a little bit more about why that is probably in the next week or whatever. But we're happy to help where we can. So if you're really interested in like, I want to write my own neural network, I definitely can't teach you to do that. It's a pretty heady topic, but I can link to resources to do that. In general, most artists I know are using other people's neural networks. Just because building them and testing them and making sure all your parameters are clean and everything is a messy topic. And it's why people spend months of their lives building a single neural network. So we'll talk about like sort of approaches to messing with these networks and that sort of thing. But in general, like I want everyone to feel like they're being accommodated. So even though we will sort of be like, I would say in our lectures, probably skipping some of the guts of like a Python, model or whatever, we will be able to support you in those ways outside of this. So we'll talk about those probably like in the next week or so. But yeah, just so people are aware, like this will be like, my hope is that if you don't have to learn anything in this class except like press shift return to run a cell edit like these 3 variables and then run it again. Like that's the hope for this class. And hopefully you learn, like you even if you don't know about, like, even if you do know Python, this will still be valuable because all these models do different things, and learning about how they work and what they do is going to be valuable. So just FYI, we'll make that more apparent to folks as we go through it. So there were kind of prerequisites for this class, but also not really. Leah sent out an email that just sort of had links to a couple videos. So as long as you watch those, you understand like what a machine learning or deep learning model is in terms of like inputs versus outputs, what a model is, like those sort of things. You'll be fine for this class. If you want more videos, you didn't feel like the ones you saw were helpful enough, I'm happy to link to others. The other thing you will need for this is a Google account. Colab doesn't work unless you have a Google account. So set up a dummy one, set up a burner, do whatever you need to do, but unfortunately you will need a Google account in order to use Colab. Okay, now we're ready to get into who we are. So I'll make this really quick because I feel like we're already behind on things. So I'm Derrick. I'm a web designer by day, and then I do a lot of machine learning art by night. I will spare the folks, like half the folks who've already seen this demo of me. I've previously like learned a lot of this stuff through SFPC, other things, and for the past year or so, I've been like pretty much devoted to working on this in my after hours. This is some of the work I produce. This uses a pretty wide range of different neural networks, and I've started doing more video and audio reactive stuff. So, you know, there's a wide range of things you can get into. So I heard people were interested in illustration, video, interactive installations. Like we'll go over a lot of different things on how to maybe work with some of that in each of these models.
Oh, and me. Next slide. Yeah, so I got started with machine learning. First, I was a machine learning software engineer, and then left that job and like dabbled a little bit in academia and like worked with some machine generated images, and presented at a workshop on creativity at NERDS 2019. And then, yeah, and then I went to school for poetic computation, where I kind of, began to fully integrate like more like the artistic side and also the machine learning side. And next, and then this is just some of my work. I think, generally I'm interested in video and sound reactive stuff. And this is a Stallion model trained on some flowers. Next. And this is a next frame prediction trained on the beginning of an Adult Swim off the air episode. Yeah, just interested in making like cool looking videos that are reactive to sound.
Leah, I'm gonna stop sharing and let you share so you can control this walkthrough if that's cool.
Sure, yeah.
Awesome.
Cool. So some basics. We're gonna go through like what is Google Colab, why would you use it over some other tools we have access to. So yeah, what is Google Colab? It's from Google. This is particularly nice sometimes because it's integrated with the Google ecosystem. So if you have your models stored in Google Drive, then it's pretty easy to like mount your Google Drive, and then you don't have to like download and upload a really big pickle file. It gives you access to Google's Linux-based GPUs, which is really nice because you don't have to get your own or rent a cloud server. It's also, the general structure is, if you ever used a Jupyter notebook, it's essentially just a Jupyter notebook with a GPU that you can use. So it's pretty easy to walk through. And the great thing is that it is free. And we put a little asterisk here because there is a paid version of Colab which gives you some access to some better features. But yeah, I don't personally have Google Colab Pro, and I do fine. Within Colab, there are text and code cells. The text cells are just markdown to just like put like a heading and some text. And then there are also code cells which contain code that you can run directly. There are dependencies included, which means like you can go ahead and install, like you can pip install and install various libraries that you need. You can pull GitHub repos and then have access to them within your file system within Colab, which is really nice because it can be like a closed little ecosystem where you install your dependencies and then run your code. And then it has web URLs, meaning that it's like pretty easy to like make a notebook and then share it with someone else, and they can go ahead and run your code without needing at all to like git pull and install the stuff themselves. It just makes sharing code really, really easy. Some negatives of Colab are that there are time limits that Google will give you the GPU for. So for free Colab, it's usually around like 8 or 10 hours. With Colab Pro, it's about 24 hours. There are also some GPU and CPU limits. Depending on with free Colab, it's kind of like a luck of the draw with what kind of GPU it'll give you. And yeah, if you pay for Colab Pro, often you'll get a P100 GPU, which is like a little more powerful. And yeah, you should think about whether you like Google and your relationship to Google as a company and using their products. Yeah, Colab is free, which is really, really awesome. But there is Colab Pro, which costs $10 a month. It's also only available in the US. You need like a US-based Google Payments account to pay for Colab Pro. It gives you 20 hours of a session with a particular GPU versus the 10 hours that you get in Colab Pro for free Colab, which you probably won't run into this time limit when you're doing just inference with the notebooks that we're showing you. But for training, if you're training something for like 3 days, you'll run into these limits, and there's some like hacky ways to get around that. And with Colab Pro, like I said, you have a higher chance of getting a good GPU. Often you'll get a P100. And yeah, I know some of you have taken the Runway class or played with Runway before. Colab, in comparison with Runway, Colab is free. Unlike Runway, you have to pay like 5 cents per like second or minute of running, I forget. But yeah, Runway will charge you for any model you run when you're running their remote GPUs, whereas Colab is completely free. With Colab, you can use audio and video. So you can import MP3s and videos and have access to manipulate them. Whereas with Runway, you're just kind of restricted to the user interface that they've written. And you often have more control in Colab. The downside is that you don't have access to like that nice intuitive GUI. And it's also a little more error prone, and you will need to debug from time to time and like read the error message and be like, I need to Google this and check a Stack Overflow for this. And yeah, do you guys have any questions about Colab? Or like, can Colab do this?
I was just wondering, you said 10 hours, but it's versus 20, but what like period of time is that for? Like 10 hours a month or just total?
No. So the 10 hours is like, if you have a notebook open, once you connect to like a runtime, they'll give you a GPU, and then you have access to that GPU for 10 hours in free Colab, and then in Colab Pro, it'll be 24 hours. So that's like if you're like running a particular cell, and it might take several hours depending on like how big your video is or how much you're processing. So yeah, you often won't hit that, but you might hit that if you're doing training. And in those cases, you'll need to like do some hacky things to get around that. Does that make sense?
Yeah.
Okay, cool. Awesome. Yeah. Now Derrick is going to do a little demo using all the beautiful selfies you guys sent.
Actually, I think we should take a break because I just broke something. So let me fix that over our break, and then we'll do a demo. So we'll try to do breaks every like 45 minutes because I know like everyone's sitting around. It's like getting like a little wiggly and whatnot. So why don't we take a 5-minute break? So let's come back at 23 after, and we'll do the demo, and then we'll jump into some other demos as well. Cool. So see everyone in 5 minutes. Before we start, were there any questions based on what we talked about prior to our break? Cool. I assume you're just like, can we just get into using Colab? So let's do it. All right. So I'm going to share my screen here. So this Colab notebook is linked to from their slide deck. I will say this is a very poorly documented Colab notebook because it is mine. And we'll talk about that more next week in the sense of like, if you're sharing your notebook, you should document it well. If you're just using it for yourself, you can be as sloppy as you want to be. We'll do a full like Colab demo right after this sort of demo, but I just want to show you sort of like what I think is really cool power of Colab. So if you've taken my runway class before, you know I have a model in there that allows you to generate like sort of floral images from your own photographs. So we're going to run that model. So again, we'll talk about sort of what's going on here, but essentially I'm in Colab, I'm installing all of the necessary files and things required to make this work. All we're doing here is we're git cloning in this repo called MUNIT. We're installing some dependencies and we're making a bunch of folders. If you're familiar with bash scripts, essentially this is a bash script that's just running inside of a cell. We'll talk about that more in a minute. It should just about be ready to go. I'm going to skip using Google Colab for now because it's not necessary. We'll talk about that more later. Let's just stop that. So when you run a lot of stuff inside of Colab, you have this nice little file viewer. This is a pretty common viewpoint. The thing about this is like for a lot of these models, you have to sort of know where things go, right? So in this case, since I've worked a lot with this model, I sort of know that where I need to upload files to is into my datasets folder and then this particular folder. And so what we're going to do is we'll just open this. I downloaded everyone's photos here. Thank you for sharing them. I'm going to upload them. Uploading single images to Colab is pretty quick. It's just like uploading a file. You can just drag and drop just like you would anywhere else. Now that all these are in here, what this cell is going to do is it's really going to go over every image inside this folder, and it's going to run a Python script called test.py, and it's going to basically do this conversion. So in Runway, you upload one image at a time, you get like one image back, right? What's nice about this is what we're actually going to do is we're going to go over the entire folder at once, and we're going to be able to say how many images do I want back for each image that I send it. So in this case, I'm going to send it 10 images. Now again, this is kind of a fancy way of like running a multi-file process that uses a script. We'll talk about this more next week. But essentially all I'm doing is I'm passing this into a function that then loops over the folder images. And for every file inside that folder, we're going to generate a random number, and that random number will be our starting point. So if you use seeds inside of the Runway model, this is going to be what's my starting seed. And then it will add for each, let's say it starts at 100, it'll go 100, 101, 102, 103, and it'll generate an image for each one of those seeds. So I'm just gonna run this really quickly. It'll probably take 5 minutes to run this across this handful of photos here. And you'll see it's outputting it's sort of like printing out like, here's the file I'm working on now. One thing to note is if you've ever used OS system where you pass a command into a system, you don't get good error messages back. So 5 minutes ago, this thing was clearly not working, and I couldn't figure out what the error was. So I ended up having to pull this line out and test it myself. Again, what's sort of nice is like, because I'm in a Colab notebook, I can go ahead and do this. So I can just copy this command out, paste it into its own cell, and then I can run that and sort of see what's happening. So as you'll see, this is processing through these images. If I go to my outputs folder here, you'll see each one of these is now a individual folder. And inside this folder are 10 images. And each of them starts at a random number. So this one started at 861. This one started at 693. This one started at 1000. So let's take a look at the images we're producing. One of the nice things about Colab is you don't have to download these images unless you want to. You can just double click this image and it'll pop up in the side panel here. And there we go. There's our flower person. So there's 861. There's 862. So each of these is a little different. So what I will do is once this is finished, I will upload these images into Slack so that you have access to them. So I'll share them with each person that shared their selfie with me. If you didn't share a selfie but would like to have this run, just drop another selfie in there and I'll post it. So hopefully you can see that this is sort of like the nice thing about Colab, but there's also some headaches, right? Like having to debug this was not easy. If you don't know Python, maybe writing this script isn't the easiest thing either. But I think it's like a nice way to get started and to sort of like, you can play around with this stuff. For me, I didn't know how to write like this sort of looping through folders thing until I decided to do this. And I was able to go into like, I was just able to Google it, Python, loop over images and folders, and I was able to find this code and then run this. So part of this is like, what's nice, you can just experiment in these cells. It'll throw an error if it doesn't work. You come back, you figure out what you did wrong and you fix it. So any questions about this process? I'm sure you have a lot of questions, but any questions about this particular process? Silence, okay. Well, why don't we, this is gonna be a more exciting thing and then I ran into issues with it. But okay, let's jump right into just using Colab and then we can, hopefully we'll have more questions based on that. So let me switch back over to my slides here. So we'll start with Colab by just using this intro notebook. So you're welcome to follow along with me or just check on the video afterward and follow along yourself again. So this is a little notebook here that just allows you to sort of walk through sort of how text versus code cells work. So these always link to my GitHub repo. Part of that is because sharing permissions, if you've ever used Google Drive, are kind of a nightmare. So I save these to my GitHub, and then there's always a little button at the top of them that says open in Colab. So if you click that button, that will open this file immediately in Colab. And one thing you will see is, you'll have a new file open and available to you. I happen to have two different Google accounts. One is on Colab Pro and one is not. So I might switch between those two just sort of show you like the slight differences in experience between those two. Let me just see that let me see what there are some chat questions. Okay, cool. So yes, Leah posted the link to this in here. So actually what I'm gonna do is I'm actually gonna switch this to my non-Colab Pro account just so we can look at sort of seeing what the difference is there. Most of you will probably not be using Pro, which is totally fine. So let's take a look at that. So let's just walk through some of the interface things inside of Colab. So the most important part to realize is that there's sort of two different types of cells inside of Colab. So the first is a text cell. So what's nice about these is you can just read. So a well-documented notebook that I will try to put together will include a lot of text about here's what this cell is doing, here's what to think about, here's how it's working, that sort of thing. So oftentimes you'll sort of read these things. There are also code cells. Code cells are these gray cells. When you click into them or when you hover over them, they will have a little play button next to it. That means you can run that command. So in this case, what you're gonna do is you'll come in and you'll just come here and you can either press the play button or you can press shift enter will also run this. So you'll start by pressing the play button, but most people now just use shift enter because it's a little bit faster. So when you run this, it'll give you an error. It'll give you a message saying this is loaded from GitHub. So it's just a security thing. This will happen pretty often based on if you're opening GitHub links. You run this, our little spinner here like runs this command. and it outputs to this area, which is just, it's a print command. So you just ran a code cell. So this is Python. A print command, if you want to just print text to this output, is just print parentheses, and then you put your text inside of what's called a string. So it's either single quotes or double quotes. Okay. So those are the two like big things: text cells, code cells. To edit these, you'll click inside of text cell. You just double click. This is Markdown. So if you're not familiar with Markdown, you don't really need to know exactly how Markdown works, because you've got these like sort of WYSIWYG tools up top here. So if you're interested in just like, you know, editing some of this, you can use these tools here and this will be fine. Basically, you can also look up Markdown and sort of understand how it works. Markdown is a way to sort of like simply format HTML. So the output says HTML. This is like an H2. There's a paragraph. Here's how you do links. I never remember the format of these links, so I always use the link button. That's how you do a link. And then for code, you can just click inside the cell and you can edit it, and then you just run it again. So text and code cells are like the most important part of Colab, but there is a whole like functionality here outside of this. The ways to add a brand new code cell or a new text cell is, excuse me, you can click these buttons up here. I don't know many people that use that tool. What I tend to do is I hover in the middle of the screen, sort of above or below where I want to add the cell, right? So if I want to add a code cell below here, I can add that. I can add a text cell by just clicking new text beneath there. That's probably the easier way, because otherwise it depends on having to remember where your cursor is positioned to add these here. A common thing that you will want to do when you first open a notebook from GitHub is you'll probably want to copy it to your drive. So if you click this copy to drive button, I do recommend that you have a Google Drive account as well. You probably don't need a big one. I think they come free with like 10 gigabytes or 100 gigabytes or something. So just using, even if you have a burner Google account, just setting up your drive to set up, to like sync some of these things will be helpful. The problem is that you can't save this file until you've made a copy of it, or until you've saved it into somewhere where you can edit it. So a lot of times just opening these files, you can't really save them until that's done. Let's take a walk through sort of what's up here at the top of the page. So this is probably pretty common, like file behavior. File is just, view, open, upload, save. You can download these files if you want to run them in like a Jupyter notebook. Colab is based on Jupyter notebooks, so anything you can do in Jupyter, you can basically do in Colab. There's some issues with that. We'll talk about that more in a minute. But essentially, these are sort of your file commands. There are some edit commands. I tend to just use the GUI that is in the interface and not these as much. I honestly don't even remember like any of these key commands. I pretty much rarely ever use them. View, so we'll talk a little bit here along the side about table of contents versus notebook info. If you want to see your code history, these things are all available here. I honestly there's a couple of these that I tend to use far more than others. Insert, so if you want to insert cells using this instead of this or this, you can basically do these things in 10 different places. Runtime is a pretty important one. I'll talk about that in just a minute. But runtime is basically, again, your Colab notebook is inside of a server. So this is managing that server and whether it's on or off, and the type of runtime type you're using. Tools, if you want to like sort of check out your settings, those sort of things, and then help. One thing that you might be interested in inside of tools is the settings command. I know Lia uses the dark theme, so if you're into the dark theme, you can switch to that. I just tend to use light theme because I don't really mind either way. We'll talk in a minute about the custom snippet notebook URLs and how to use that. If Colab Pro is available to you, or if you want to sign up for it, it is available within here. There are some other things around, like if you want the font size different, if you want to change indentation. One thing you might want to do is to show line numbers. So if you're writing a lot of code into cells, this might be helpful for you. There's a number of other features in here that if you want a more full-fledged editor, you can do that as well. Inside miscellaneous, you'll see this thing power level. Never turn this on. You can turn it on and play with it, but like it is a nightmare. It's like kind of a game. It's just like one of those Google Easter egg things, but it is not fun if you forget you turned it on and then can't figure out what's going on your page. Just FYI. Save that. Along the left-hand column here, these are sort of 3 important things to know about. So the first is table of contents. So basically what this will do is it will take all of your formatted text cells and it'll give you sort of an outline of what the page has available to it. This is helpful for really, really long notebooks where you might want to jump from like one section to another. In most cases, also just sort of helps you understand, like I try to structure mine. H1 is the very top level. H2 are like sort of sections, and then H3s are headers for each of those. So you can sort of see how the page is outlined. This one is code snippets. I will talk a little bit more about code snippets in just a minute. There are a lot of code snippets here. So if you're ever trying to do anything that like I have not talked about yet, but you're interested in, you can kind of search through here. So opening files from GitHub, opening files from Google Drive, things with Pandas or whatever. Like, so there's a lot of different tools in here. I personally like very rarely use these. I have a list of custom code snippets that I do tend to use more. That's these things with underscores, and I'll show you how to set that up in just a minute. And the last thing, this is the page, or this is the tab that I'm most using. This is the files tab. So this is where, as you save things to your server, this is a like outline of all of those folders and that sort of thing. It's important to know that most of what you are doing will happen inside of this view, which is the /content folder. There is also a top level view where sometimes things get saved to. This is the like root folder of the server. But pretty much everything you're going to want to do is going to work inside of this folder, which is content. So when you run anything directly from here, like if you just run, let's just do this. Let's just do pwd. You start in the /content folder. So just remember that, because that will definitely like trip people up. All right. Any questions about UI or anything before I jump into this notebook? More silence. Okay, quiet group today. We'll get you talking soon enough. Cool. So the number one thing to know about pretty much every notebook that we're going to run is that you need to make sure your runtime is set to GPU. So a lot of times when you open these for the very first time, you will see when you come into runtime, change runtime type, hardware accelerator will pretty much always be set to none. Pretty much the first thing you want to do whenever you open any brand new notebook or create a new notebook is come over to hardware accelerator and turn it to GPU. Now this is because most of the deep learning stuff we're going to run needs to run on a GPU in order to run at a decent pace. If you run this not on GPU, it will be very, very slow. So if you're running something and you think it's like running like at a snail's pace, it's likely that you're still running in CPU. Now the problem with this is that if you've done a bunch of stuff like installed code, run a bunch of things, when you go to switch it from CPU to GPU, you will lose all of the things you've installed. So this is why I sort of recommend that like you set GPU for the very first thing you do when you come into Colab. It just saves me headaches. I still do it all the time. I still will often create a notebook and then be in CPU mode, and like 20 minutes in, I realize that I'm still in CPU and I have to restart. So it's fine. It happens, but just be aware that this is sort of the most important thing you want to have set whenever you open a notebook. So you'll see I just set that to GPU and it restarted my machine. It restarts very quickly, but if I had saved data in here, I would have lost it. All right, so we went through text versus code cells here. The next thing to remember is that these are just like, this is like a shell command or you're working in terminal. So basically all you're doing is when you run one of these commands, you're sort of in your terminal running a single command, and then you run the next command and then the next command and the next command. So in this case, what we're going to do here is we're going to run the command and we're going to save these variables. So we're going to save 12 to be first number and 25 to be second number. So these are just saving these variables in a Python environment. So like when I run this, it ran very quickly and then nothing was output because I didn't ask it to output anything, but it saved these values as variables. So when I come down to the next cell, now remember, it remembers what those variables were because I ran them previously in the session. So when I run this cell, which is going to just output this, and it just outputs, this is like a Python string for formatting. All it does, it says, okay, so the first number is 12, the second number is 25, and then in Python, you can do a little bit of math by just using the plus symbol, and it equals 37. Cool, so like that makes total sense. Now, the thing to remember is that because this all happens sequentially, let's say you, like later in a notebook, you're changing the value of this variable, and you say, my second number is now 25, now 30. So you're gonna hit shift return, so you're now gonna save this variable. Now, if you can play these cells in any order, but the order in which things were saved matters. So if I come back up here and run this cell again, and it's the exact same cell, but the variables have changed in the environment in the sys session, you will see now 12 plus 30 equals 42. So order matters, and it's just helpful to sort of remember that like your order matters. I generally don't recommend setting variables twice in different cells because it'll get really confusing if you like have a place where you're trying to sell your variables and then you like quickly throw in something new in there just for debugging. It happens a lot, but just remember that this is sort of the case. One thing to note is you can sort of tell what order you're in by the numbers here in these upper left-hand corners, right? So if I click out of here, so this one was ran, this was the first cell that was ran, actually it was the second because it's 0 indexed. Actually, it's not 0 indexed. I just didn't run this when I restarted that GPU. So 1, and then this was 2, but it's been overwritten. This was 3, and then this was 4. So you can kind of follow the command a little bit. It's a little confusing, but you'll get the hang of it as you get more and more used to it. So GPUs. So like Leah mentioned, with Colab, you get a variety of GPUs if you're not on Colab Pro. The one way to tell, and I recommend this a lot, is to run this command. So this is NVIDIA-SMI. You don't need to know what this means. This just means show me what GPU I have. When you run this command, you will see that it outputs a bunch of stuff, and you might not know what that stuff means. The main thing you want to look at is this right here. So GPU, this is our first GPU, and it is a Tesla T4. Now, what is a T4? It's just a server GPU. You don't need to really worry about it. You could look up the specs online if you're interested. The next important thing to know is what this number represents. So this represents how much VRAM is on your GPU. And this says it's about 1,500 megabytes, which means it's about a 15 gigabyte VRAM GPU. The size of your GPU matters a lot, especially if you're going to be doing stuff like training. For a lot of what we're going to be doing in this class, it probably won't matter. There are 3 common GPUs that are offered by Colab. The first is a P100. This is the best of them. It is 16 gigabytes of VRAM. The second is a T4, which is 15 gigabytes of VRAM. This is what we have now. And the third is a K80, which I feel like they're phasing out slowly. It is 12 gigabytes of VRAM. Now, VRAM is important because VRAM is how much memory load you can put on these GPUs. But there's also a speed component. And I think based on what I know, like this is the level of speed. So a P100 is faster than a T4, which is faster than a K80. In general, like you can look up the specs for these, but this is based on what they call T-flops. That's a very technical term for how many seconds or whatever like these GPU can run on a certain amount of data. So just to remember, like ideally you get a P100, but you don't always, especially not in Colab and when you're in regular Colab. If you are in, let's see if I have anything else here I need to worry about. I don't think so. If you are in a CPU, so let's say I turn this off and I come back here and I run this cell, this will run an error because there is no GPU driver set up. So this is a nice way to also remind yourself, like, am I using a GPU or not? So if you get an error message here or this line that says NVIDIA SMI has failed, that's because you're in a CPU. So you can come back here, switch it back to GPU. And if I run this, I might get a different GPU type. Sometimes it happens, sometimes it doesn't. We'll see. Yep, so I still have a T4. So I think T4 tends to be what they're mostly giving to people not on Pro. But anyway, this is what you'll get. We're running a little short on time, so I'm going to quickly run through this. And I recommend just sort of reading through this at your own pace at a later point. Colab can do a lot of other stuff besides just like running a command, right? There's a thing called snippets. I have a video that shows how to embed a custom snippets file into your Colab. It's helpful. Like, I am terrible at remembering Python commands, so I tend to use a lot of snippets just to remind myself how certain things work. So snippets will be helpful for you in the future, and you can keep yours up to date. You can have your own snippets file and add to it as you learn more, or as you just sort of learn what works for you. Google Drive integration. So Leah mentioned that because this is Google, it's all synced together. So there's a really nice way to sync your Google Drive account. So if you run this command, which just basically says like add Google Drive to my account, then you go through this process of clicking these links. And it always asks you to go through every one of these steps. It is very annoying, but it's a nice feature in return. You're going to paste in this authorization code, paste it. And this will do a little bit of running. And once it's running, it'll say you are now mounted at content/drive. So if I go in here and hit refresh, this is a really important button. Oftentimes you won't see stuff refresh in your folders. So just make sure you click this button and you'll see updates and refreshes. So in here, this is my entire Drive account. This is 2 terabytes of data that is now available to Colab. And you'll see us use this fairly often, especially when we talk about training. You will basically like mount this and then save directly to Drive for a couple of reasons. We'll talk about that in a couple of weeks, but this is a really, really helpful feature. I know some folks who are not in the US or abroad, like sometimes have issues with Google. There are also ways to sync stuff like Dropbox and other things. If you're interested in those, let me know and I can send you some info on that. But in general, this is sort of the best preferred way to work with Google Drive in Colab. Now, if you've ever used a Jupyter Notebook, you know that there are like things to use for GUIs. There are like command line tools. You can plot things, you can visualize things. We'll go over a little bit more of that next week, or you might see some examples of that in the notebooks we'll give you this week. But just know that you can do like a pretty decent amount of work within Colab by just sort of editing things. Because this is a web page, that you also have access to like using HTML elements. It gets a little funky to sort of make it all work. But we have some examples of places where people have done that. And it's worked pretty well. I mentioned that these can work with Jupyter. A note to work with Jupyter Notebooks is that often Jupyter Notebooks are ran from inside of a folder. So like if you're on your local computer, you download a GitHub repo and then you open that Jupyter Notebook inside of that folder. So a lot of times those Jupyter Notebooks won't tell you about all of the code you need to install or the dependencies you need to install before running. So a lot of times you'll find a notebook and you think you can just run it and then there's a bunch of errors because things aren't installed. So this is one of the issues. You'll have to do some debugging. So just be aware of that if you are familiar with Jupyter Notebooks. Okay, that was a huge introduction to Colab. Are there any questions? Like basically your homework is going to be like open a notebook and play with it a little bit and try to get familiar with the interface. But I know that this is throwing a lot of people all at once. So any questions?
If you're not familiar with Python, is there something that I should watch beforehand, like before I jump into any of this?
I would say that like most of I can point you to some notebooks that are well documented. We'll talk about this in just a minute, but there's also different approaches to notebooks. Some notebooks throw all the code in a cell and then you like have to read a ton of Python. Others just run scripts and they'll like tell you what the arguments are. So I can link to you, I'll add some links to like really just general overviews of how Python works. But I would say for the majority of this stuff, you shouldn't have to know too much Python, as long as you can understand that like, here's a variable that I'm setting and then that is getting run in a command. Like that's pretty much all you're gonna need like to know for this course. Obviously like some of this might get more complicated. You might open a notebook and be like, I have no idea what I'm looking at, in which case you can always reach out to Leah or I and we can sort of help walk you through things. But yeah, I would say like in general, like Python is semi-important to know in a lot of this stuff, but not a requirement. Any other questions? Cool. All right. So I know people are probably anxious to just get started. So we're going to talk a little bit about where to find notebooks. So yeah, you're probably wondering like, okay, I've seen a couple of the notebooks that you have. Where do I find other ones? So here is a list of sites where there are various notebooks available to you. ML Art Collabs is one that I run, and Leah helps contribute to it. This is probably the one that I would recommend you start with. we'll look at in just a minute. But there are also, like, if you just Google, like, literally, like, you know, machine learning notebooks, you will find many, many options and articles. Here are some other ones. This Towards Data Science tends to be one of the better, like, machine learning article sites. It's all run on Medium. It tends to have a lot of good explanatory articles if you're ever interested in digging in. These are 3 or 4 other links to other Colab notebooks. I haven't vetted most of them, so you may, if you're like not super comfortable with running this stuff just yet, I may recommend you start at our ML Art Collabs, play with 1 or 2 of them, and then go from there. Lastly, if you've heard of like a machine learning model you really want to play with, I can almost always Google like a model name and then space Colab notebook, and something will pop up. Because these are like web searchable, because they're like saved to the web, lots of times you will find links to them. Now, whether they're in good shape, whether they can work is a different question, a different story. But you will often find examples of things that exist on the web that are Colab notebooks you can open and play with. So as I mentioned, there's a couple different notebook styles, and you'll see different authors of different notebooks sort of approach things in different ways. My preference is toward like less code in front of you and more like descriptions of how one command works. So I will tend to do things like run a Python script and then use a thing called argparse, which is just passing in a bunch of arguments into that script. That means that your code tends to be like a block of variables and then a 1-line like script command. That tends to work best for me. It's just how I tend to like to work. I think it keeps notebooks a little bit cleaner and less code heavy. But other folks like to do the second method, which is they will take all of the code from individual repos and bring it into a code cell, which means you might have very tall blocks of code, but they're essentially doing the same thing. So that's what's important to know is like many times these 2 things are doing the same thing. They're just doing them in different styles. So in the ML Art Colabs notebooks, you'll see some examples of both of these. The other thing to note is that some people go really heavy into like GUI tools, like here's a slider to do this thing, or here's a drop-down menu to do this thing. And others will not use GUIs at all. And other people will do a thing where they can like hide code by using some like very like specialized Colab notebook commands. So sometimes you'll be like, there's a headline, but I'm running code in it, and you'll be a little confused. It can all get very confusing, which is to say like there are various notebook styles, and part of what I hope you get out of this class is like you can get a little bit more comfortable with those styles. And if you have questions, Leah and I can help walk you through those things. So the GUI versus no GUI is something we'll definitely look at more next week. We'll look at a couple notebooks that use GUIs. And you'll find that like, especially with deep learning, they're a little iffy because the refresh time in a lot of these models like is a little slow. So we'll look at that, and you'll sort of see like how you can start to introduce GUIs into a notebook and understand how to play with them. So some warnings. If you're trying to convert like a GitHub repo to a notebook, you may run into some issues. I find that every time I try to do this, I have about a 50-50 success rate. Most of the time what happens is that a lot of machine learning models are very poorly documented. They don't tell you what dependencies it has. They don't tell you like what version of TensorFlow you need to be running. They don't tell you what version of PyTorch you should be running, or like what other like requirements it has, or how big the GPU needs to be to run it. So in general, if you find a very poorly documented GitHub repo, I would recommend just avoiding it. Like it just means that like these people don't care that much about you using their model, and you probably shouldn't use it. Another thing that's pretty common, and I've actually like we've started seeing this more and more with even with the models, the Colab notebooks that we've shared, they do get out of date. So sometimes what will happen is at the time that the Colab notebook was written, it was perfectly up to date. Colab, which has a bunch of dependencies that it auto updates over time, those updates might break things. So then you have to go in and figure out like, oh, I need to be running an older version of PyTorch, or I need to be running an older version of this particular pip dependency. This can be a challenge and can be very, very frustrating. Again, this is a case where like reaching out to Leah or I, and we might be able to help with some of those things. I even noticed in one of Leah's videos that she recorded last night, and we'll link to some of those. She ran into one of these and was immediately able to figure out what happened because she knows what she's doing. If you run into questions, we can probably help debug things. As I mentioned with Jupyter Notebooks, Jira notebooks are kind of usable in GitHub, but often need some updates just to make sure that you're installing the right dependencies and installing all the things you need to. So just be aware of that. If you do happen to find a broken notebook and you figure out how to fix it, or Leah and I can help you fix it, please let us know because we can always update those links in our GitHub repo. And we'll obviously give you credit for fixing it. Likewise, if you make a brand new notebook from a model you find, let us know because we'll happily link to those as well. And I think, you know, just like you're in this class because you're interested in this topic, there are lots of other people who are also interested in finding new models to play with. So we'll happily credit you, and more people will be excited to make things with notebooks you make. Okay, so let's see, how much time do we have left here? So we are at, okay, we have 1 minute left. Okay, we might run a little bit over, just a couple minutes. So your assignment for this week is just to find a notebook and just play with it. So like that means basically like open it, like get your GPU set up, run a bunch of cells, try to produce things with it. Now I'm kind of throwing you in the deep end because I want you to struggle a little bit, and that's okay. Like I'm not trying to like make you this class painful. I'm just trying to like, so you understand that there are some hurdles to this, but also that Lee and I can help you walk through with you, some of these things with you. So if you're into issues, let us know. We're happy to walk you through things. What I would love for everyone to do, if you want to do all the homework assignments, find a model you like, and then play with it, try to figure out how it works. And then in our class Slack, like post a link to the model you used, or the Python notebook. And then just a little bit of like what you experienced in using it. So maybe what you figure out the inputs and outputs were, where it broke down or where you couldn't get to work. And then if you make cool stuff, show us what you made. Once again, there is a link to a bunch of different repos here with different notebooks. I would probably recommend starting with ours. Leah and I, if you're also interested, if you feel like I'm way in over my head and I just want to watch someone else use one of these, Leah and I have made a playlist of a handful of models. So Leo just last night went through a couple, and she made one for what's called the 3D Ken Burns effect. Also did one on, if you're interested in audio machine learning, there's some cool audio machine learning. So we have a list of like a small amount of Colab notebooks here. I'll probably be adding to this over the next week or so. So if there is one you saw and you're just like, I can't figure this out, I'm happy to record a demo and post it to our YouTube channel. So, but basically like just start playing around. So let's take a look at this notebook, at this repo. And let me just walk you through some of the notebooks here. So we've tried to organize these based on like what they do and how they work. I recognize that some of these names might be completely obscure and like not obvious to anyone what they do. So if you have questions about some of these, let us know. We're happy to walk you through things. If you are feeling like I'm a little uncomfortable digging into this immediately, there are two notebooks that I'd probably recommend you start with. The first one is this called SimGAN. So I just recorded a long video into how this one works. You're welcome to follow along in the video, but also like these are two notebooks that I've used previously in other classes, and my hope is that they are very well documented. So in this case, you know, if you come in here, you'll see that there are lots of text comments about how this thing works. Where do I go to find this like information, that sort of thing. So this should be well documented. It should be able, if you read, you should be able to walk through the notebook without any issues. If you're in issues, let me know. The other one I would recommend is the Neural Style TF notebook. So here again, I actually recorded like an hour-long video on how this one works. But this one is also like, it's 12.3 megabytes of text. It might actually, oh, okay, so cool. So this one is also fairly well documented in terms of how it works. So if you're looking for just like, I want to get started and I want to sort of like read a little bit and walk through it very slowly, these are the two I'd recommend. The other ones that are here, you will sort of find that like some of them are in various states of documentation. So this is a MUNIT one, which is sort of, it's a little different than the one that I previously showed, but it does work. Next week we'll be going over probably either Lucid or Lucent, as well as the Deep Dream, this notebook by Alex Mortvinsev, who created Deep Dream and created a really cool notebook for it. So that's not to say you shouldn't look at those, but if you do look at those and you're confused, we will be going over them next week in depth in this class. So just to let you know, we'll be looking at those. Other ones I think are pretty, I think the image colorizer one that I just looked at last night, and I meant to record a video of it, just sitting around to it. This one's also fairly well documented. And Leah has videos for the Ken Burns effect. as well as the DMOOCs here. So this class, we won't really be going into ML audio, but if you are interested, there's some cool models to play with here. And similarly, like, I'm not really a text person, but if you're interested in GPT-2, there is a good notebook here as well. So yeah, so your homework is just like pick one of these notebooks and like play with it for a little bit. And if you run into issues, that's totally fine. That's like normal and happens a lot. In that case, just reach out to Leah and I, and we're happy to walk you through things. Also post notes in Slack or post questions in Slack. And anyone who like is also familiar with this stuff or like knows a little Python or whatever, or might do some error debugging, you're always welcome to respond in Slack as well. Whew, that was a lot. Okay, how is everyone feeling? I'm losing my voice, but cool. Okay, any questions before we wrap up for the day?
I just have one question. When we were reviewing Runway, I know there were some limitations in terms of like image size. And does Colab save us some of those limitations, or I don't know, create some flexibility?
A little bit, but actually most of those limitations are GPU based. So again, this is a case where running that NVIDIA SMI command will also help you understand what's going on. So if you're uploading an image and it's like 720 by 720 and you get out of memory order errors, check to see if you're on one of those K80s, because those K80s will have bigger issues with image size and that sort of thing. So if you can, try to get to one of those P100s. Again, this is a case where like $10 a month for a GPU is actually a fairly decent price. GPUs cost about $1,500 to $2,000 out of the box or more. So $10 is actually fairly reasonable if you can afford it and if you want to. Those will guarantee you like a P100 almost every time, and that will be the highest GPU size you can get out of those. So you might still run into out of memory or size issues, but you're less likely to with those models, with that GPU.
Does it always have to be
Oh, I can hear you.
Can you hear me? Oh yeah,
yep.
Sorry, I'm muted. Does it always have to be 720 by, or like a square resolution? Because I always hear 512 by 512, but what about the rectangle?
That depends a lot on the model. So for example, both SynGAN and neural style TF models can take any shape or size. When we look at the StyleGAN models, you will more likely be you'll pretty much be working with 1024 by 1024 in most cases with StyleGAN. Those are limitations of the models and networks. You can kind of get around that, but it gets hairy and you run into other issues later down the road. So yeah, the size constraints are generally on a model by model basis. And that can be a challenge to sort of figure out like, what is the size I need to be working with this? Again, those are things where like, if it's not noted in the notebook, like those are good things that I don't even think of. So you should mention that to me and I'll update the notebooks and update them, because I think everyone would like to know more about that as well. So if you do run into issues where like, I can't figure out what size I should be implementing here, like let Leah or I know and we'll update those notebooks to make sure that's acknowledged as well.
Derrick, have you seen a difference in MUNIT, for example, using it in Google Colab and on Runway? Is it like the result? Have you seen a difference?
There's no difference because I'm using the same model or the same pre-trained model. The difference is in speed. I tend to find that Colab is faster. And I also tend to find that you just can do more quickly. So like the problem with Runway, right, is Runway charges you 5 cents per minute of a thing running. Whereas Colab, you can run it for 10 hours and it's basically free. So like you can, like, whereas with MUNIT or like, sorry, with Runway, like if you have an error and you like kind of spend 10 minutes messing around trying to fix it, you've now spent 50 cents, right? Whereas doing that in Colab, there's no cost. So it's really just like, it gives you a little bit less anxiety about what you're paying for or what you're spending money on. That's like, to me, the biggest benefit of something like Colab. The downside is like, you have to kind of muck through some code, Google some errors, like those sort of things. So it's definitely like not as user-friendly. Those are basically the two big differences, I would say.
Cool, thanks.
And I'll also say like, Colab can technically run any model that you can find on the internet, whereas Runway is like, the
Yeah,
process of
pretty
adding a notebook to, or the process of adding a new model to Runway is like very annoying. So it's a little bit easier to set up a brand new, like if you see a new state of the art, like sort of whatever model, you can get it up and running fairly quickly inside of Google or inside of Colab if it's well documented. And then you can play with it. Like a lot of times, like I will crack open a model, like stick it in Colab in 20 minutes, run it, see if I like it. And if I don't, I'm like, I just like save the notebook and like move on. So, you know, it's a little bit easier to just like sort of play with, which is what I like, right? And it doesn't cost me any money to like, cost me time, but it doesn't cost me money to like play with a notebook and see if it works.
Cool.
Any other questions? All right. So the other homework thing that we want you to do, and Leah, maybe you can just do this, is post our poll in the Slack channel. That way everyone has access to it. So I think that'll be it for this week. Once we have a couple more responses to the poll, we'll post when we're going to do a co-working sessions. We'll usually do them like once a week. So we'll let people know when that's available. And again, those are times where you can like come and hang out on Zoom with us, but you're not required to. And also those aren't the only times you can ask us questions. So if you have questions, feel free to post them in the in Slack, and like we'll try to respond to them as quickly as possible. So basically the way I work with Slack is like, if you're in a current class with me, I try to respond like as soon as possible. Other questions get asked in other Slack channels, and like sometimes it takes me a week or two to respond. So I will try to respond pretty much same day to you in our Slack channel. All right. Well, I hope everyone has a good rest of their day. There will be videos linked in the class site. I'll post a note in our class channel when that is set up. And Dania, I'll make sure that you get added to our class right now. All right. Thanks, everybody.
Thank you, Derek. Thank you,
Thanks.
Leah.
Yep.
Thank you, everybody.
All right. See ya.
You.
Bye.